Dr. Amit, I think I don't know why I see myself twice. Once is actually, I don't see myself, and then I see myself in another. I see twice Yona Barak.
I think, ma'am, it must be. Why is it happening? Yeah, you are. It must be that you must not have, but somebody has joined from the same link of yours. Wait, sir, हमने
yes. So, excuse me, I gave it to my son because he wanted to see it.
So that's why.
Got it. Okay.
Yeah. So two devices have logged in.
Okay, thank you.
Sir, wait, sir, आप मुझे बोल दीजिए कब start करना है. मतलब it is 5:32 now. So whenever you say, we can start now.
मेरे ख्याल से we can start now.
I am the first one. Who is the first? I am the first one.
I think Alex.
No, Dr. Alex.
Okay.
Dr. Amit, we can start now.
Should we start, sir?
Yes, please.
Thank you, sir. Thank you, sir. So a very good evening to all the faculty members and delegates who have joined for today evening. It is always a privilege to host an iHera webinar. iHera webinars have always been at the forefront at many scientific topics, and it has been a pleasure and an academic treat to hear all of webinars of iHera. I am Dr. Amit Borse, and I am a marketing manager at Emcure Pharmaceuticals Limited. IVA is a division of Emcure Pharmaceuticals Limited and is on a mission to nurture and support 28 days. Programming 28 is a scientific theme for the year, and hence all our webinars are called Programming 28 webinars. Programming 28 is based on the concept of managing an ovarian cycle with different gonadotropins, analogs, and hormones as per different protocol. Today here we are again with an iHera webinar with the theme of the unknown culprit and IVF lab, Voc'S. We are very thankful to Dr. Ved Prakash sir, the founder of iHera, Dr. Sanjay Shukla sir, and Dr. Charudatta Joshi sir, the co-founders of iHera. Dr. Ved Prakash sir is the lab director at Southern Fertility and IVF Delhi, NCR. He's the president of ACE India. He's the founder of International Human Embryology Research Academy. He's a member of Virtual Education Committee. He's a faculty fellowship in ART, Amity University, Noida, visiting faculty at MSc in ART, Mysore University. He has contributed 8 chapters to the textbook and has published many national and international papers. His area of interest is in vitro fertilization to blastocyst formation, innovation in embryo culture system. Sir, it has always been a pleasure to host your events, and we are thankful once again as an organization to give us an opportunity.
Thank you.
Session belongs to all you, sir. Please take over.
Thank you, Dr. Amit, for wonderful introduction. Here, I think Dr. Shukla and Dr. Charudatta Joshi is also here, my co-founder. So we three decided to why not to start one platform to share the knowledge amongst our embryologists. And thanks to Emcure for sponsoring this webinar. So I think I hand over to our coordinators, Dr. Rahul Sen. He's from he's Chief Embryologist. Can you please share the slides, Sanket or Mr. Amit, Dr. Amit? Do you have slides, Sanket?
No, sir, Dr. Amit has it.
Okay. So, Dr. Sanjay Shukla is Lab Director, Baheti Hospital, Jaipur, and Shivani IVF and Fertility Center, Jaipur. Next is Dr. Charudatta Joshi. He is post-graduation in life science in 1993. He is past Vice President ACE and Medical Director, Genes India ART Bank. And our four coordinators, Dr. Sanket, Dr. Rahul Sen. He is currently working as Chief Embryologist in Nilkant Fertility, Jaipur, Rajasthan. And he is a member of many societies. Sanket Dhumal, Senior Clinical Embryologist from Shama IVF Fertility and Reproductive Medicine Center, Mangalore. And Dr. Akash Agarwal, Dr. Presh Makwana. Dr. Akash Agarwal is, sorry, can you please stop it now? Dr. Akash Agarwal.
So sorry, sir. Let us
Yeah,
go with
no,
Akash,
it's
sir.
okay. Yeah, he's MBBS SRA certified clinical embryologist, scientific director, Head Fertility, Hyderabad. And Dr. Paresh Agarwal, is chief embryologist. Can you please?
Paresh Makwana.
Paresh Makwana, please. Yes. ASRM certified embryologist, and he's from Wing Hospital, Ahmedabad, Gujarat. So over to Dr. Rahul and Dr. Sanket, coordinators, please.
Yeah, thank you so much, Dr. Vetsa, for the kind introduction. So, Dr. Amit, can we have Sanjay sir's CV, please? So, I would like to welcome you all for today's webinar on behalf of IHERA. And theme for today's webinar is the unknown culprit in the IVF lab. That is the Voc'S, which is considered as the invisible enemy for an embryologist. So, without taking much time, I would like to introduce the first moderator. Dr. Amit, can we have Dr. Sanjay sir's CV, please?
I think we can straight away go to Dr. Alex's CV.
Okay.
Yeah, perfect. So thank you very much, Sanket. It is my pleasure and honor to invite and introduce Dr. Alex Varghese. He's a close associate of all of us. He has been a guiding inspiration to many in the country, and he has many credentials to his name. He is scientific director at Astra Fertility Canada and also to Craft IVF Kerala. His interest of in the ART is in developing automated system for IVF. He has many publications to his name, and he has edited many books. He owns an H&X of 14, which is remarkable, and I believe everyone in the field knows him. So I invite him to deliver his talk, especially on the how it actually hampers the VOC when we talk about VOC. A few years back, we were not actually knowing about the harm that VOCs are doing to our culture system and to our embryos. But now it is a well-established fact, and we all are worried about even the tiniest amount of VOCs in our laboratory. So, floor is yours, Alex. We are keen to listen to you.
Thank you, Dr. Sanjay. And thanks to the IHERA team, especially Dr. Varghese, to invite me to speak on this occasion in this quality series of our lectures. And the first one is on the air quality management. So the topic that was given to me is volatile organic compounds, how it actually hampers the laboratory environment. During this pandemic time, we have seen the acute effect of many disinfectants. We can say many of these laboratory cleaning agents or the UT cleaning agents. But we are more concerned about the chronic exposure. And unfortunately, many laboratories have that share the same HU system with the egg recovery room. So that could be one of the reasons. Recently, we are seeing many labs worldwide seeing some kind of a dip in their pregnancy rate. Maybe that is due to the specific disinfectant and that is seeping into the IVF laboratory. But my job today is to look at the actual, what is the actual evidences on the effect of VOCs on the pre-implantation embryos and the final outcome, that is IVF pregnancy. So these VOCs, or the volatile organic compounds, they are hydrocarbon-based organic compounds that are emitted into the air from different products or the processes that we do in the IVF laboratory or in the adjoining areas. And their composition makes them possible to evaporate under normal indoor or atmospheric conditions of temperature and pressure. And also these VOCs introduced from various sources that might interact with the samples, tissues, media, oil, and finally it will have a kind of a serious effect on the IVF outcome. We know that one of the important source, the remediating thing for the VOCs that the people use in the HU is the activated carbon. And this carbon absorbs the higher molecular weight hydrocarbons because of the pores of varying sizes and field of molecular attraction that capture the electron-rich molecules. But the low molecular weight organics, kind of alcohols, ketones, and aldehydes, that can be oxidized by the potassium permanganate that is present in some of the HU system along with the activated carbon. And some people also use the advanced technology, maybe the photocatalytic oxidation or plasma technology. In short, it is known as PCO, to fight against the VOCs or remediate the VOCs that is present in the IVF environment. So we know, as we discussed, we know that there are different sources for the VOCs. Maybe the painting, the MDF, or these wooden furnitures that we use, or some people use as perfumes, or the nail polishes, or maybe the disinfectant, and also the styrene and other VOCs emitted from the plastics that we use in the IVF laboratory tissue culture. And another important thing, especially that we see in India, is the diesel generators that is used for the power generation during the load shedding times or electrical when there is no electricity. And one of the major problem that is seen in some countries without any regulation for gases is the contamination, or there are different sources. So there are different sources for the volatile organic compounds that is generated in the IVF laboratory. So that is a major concern. So if you can make it under control by proper processes, so one doesn't have to worry about the troubleshooting processes. One of the earliest studies we can see that came from Dr. Kadujan, of the PhD student in China, that was published in JAR journal. She did a fantastic study looking at the many VOCs that is present in the IVF laboratory. This is just a snapshot of the ones that she studied during her PhD program in one of the Chinese IVF center. So we know that there are different types of VOCs that can seep into the IVF laboratory, that even can enter into the box incubator or the culture environment, even in the benchtop incubator systems, or during any manipulations done in the IVF laboratory. And this the embryonic growth and many things can be affected by maybe some kind of a DNA attack formation. I'm sorry for this. I think there's some problem with this writing. I couldn't. So there are different ways these pollutants or these VOCs can affect the cells, so that is we culture in the embryology laboratories or in the cell culture laboratories. So what are the evidences on the effect of VOCs? So let us look one by one. So we have the retrospective studies or indirect studies. We also have the in vitro studies looking at a VOC air mixture and individual VOCs on the cultured cells. I'm not talking about the embryo culture systems, but in the cell culture systems. And we have some recent studies, some interesting studies on the specific VOCs on its direct exposure by diluting them in the culture media and looking at the embryo growth or the blastocyst and the chromosomal anomalies that are being done by this VOC. So we can look at 3 levels of evidences. So the evidence one is the retrospective studies, or we can call them as indirect studies. One of the earlier kind of evidence that came from Jack Cohen's lab along with Antonio Gilligan in 1997. And they first described a detailed assessment of chemical air contamination, and they linked it to the pregnancy rate to the VOCs generated from the neighboring spaces, construction, and the cleaning activity. So they done an extensive study even in the outside air, return air, the hallways, procedure room, and also even in the incubator. This is one of the first study that happened around 2 to 3 decades ago. And Dean Morbek has published a fantastic review in JARG in 2015. In this, he done a good review of the different publications that came out in last 1 decade on the effect of impact of air filtration, especially on the presence of chemical air filtration on the IVF outcome. Several studies have shown that when they shift to a new laboratory with a purpose-built kind of IVF laboratory complex with a clean room technology, or with the carbon or activated carbon and potassium permanganate or any other kind of VOC filtration system, they have seen a consistent improvement in the clinical pregnancy rate and the ongoing pregnancy, even the implantation rate also. So this is a kind of indirect study showing that the clean environment gives a better outcome. But that still doesn't give you the exact evidence that the VOCs are the real the culprit. Interestingly, the one study that came out in 2015 from the University of Iowa Hospital group and the IVF group, this you can cite as one of the interesting evidence that pinpoint the role of VOC on the IVF outcome and the pre-implantation embryo development and the blastocyst quality and the blastocyst development. So the title of the study was the lack of air filtration and its impact on early embryo development from Dr. Van Voorhees' lab in University of Iowa in the US. So they looked at 3 periods, 3 categories. So they categorized the study into 3 periods. If you look at the first period was sometime around 2010, Jan to July, when the IVF laboratory air handler or the HU system, they contained a carbon filtration system. So they call it as a carbon 1 period. So there was a activated carbon in their HU system. And the second period was from Jan 2011 to July 2011, when the carbon filter was absent inadvertently. So without informing to the IVF lab director, the biomedical engineers in the hospital removed the carbon filter. So we can call them as a carbon absent period. And the third period was, or category was after knowing this, they replaced the new carbon filter and it was restored. So we can, mentioned in the study, it mentions the carbon 2 period or the carbon present period. So we have 3 periods. In between there is an absent period. Now let us look at what really happened. So first they looked at the cleavage rate per each zygote that was cultured. If you look at this graph, you can see a different colors line diagram. So this is the carbon first period when there was a carbon was present in the HU system, and this is a carbon absent period, and this is a carbon present period. So you can see there is a dip in the proper cleavage rate per the 2PN zygotes during this period, except this the purple one. The purple one was the frozen embryos. Only the frozen embryos had no impact, not much impact, even it was cultured in the carbon absent period. I will tell you why it is so. Secondly, they looked at the day 5 blastocyst conversion or utilization rate per zygote. A similar observation was seen. In the absent period, there was a dip in the blastulation or the utilization rate. And it went back to the normal blastulation rate in the carbon 2 period. And interestingly, again, the frozen embryos, the embryo doesn't have much effect on that particular period. And the third scenario, they also looked at the retrospectively looked at the data, and they looked at the good and excellent quality blastocyst among these whole zygote. Similarly, they got the same scenario, dip in the good quality blastocyst in the absent period, but again, the frozen embryo was not getting affected during that period. And interestingly, this particular group was freezing the embryos at the 2pn stage or the zygote stage. So we know that some programs still they do the freezing at the 2pn stage, like in Germany and some other places. But that really gave some kind of evidence on the effect of VOCs. So what they concluded, the interpretation from the study is that the absence of significant change in the cleavage rate, blastocyst conversion rate, or the good quality blastocyst development rate from the cryopreserved zygote while carbon filtration was absent, that clearly suggests that the lack of carbon filtration affect the embryos, especially in the peri-fertilization period. So it is during that fertilization or 2pn stage where the recombination and the chromosomal exchange happens. That is a very vulnerable period that is has to be taken care properly. So from the beginning of fertilization or insemination, the VOC effect can happen. So that's what we have seen, not much effect of the 2pn frozen zygote that was cultured during the carbon absent period. And this tells that this VOC-induced depletion of some of the antioxidant and VOC exposure may decrease the embryo's ability to defend against maybe some kind of oxidative damage that is emanate or that might come from this the VOCs that are present in the IVF laboratory. So this is one of the retrospective study giving a good indication or evidence on the effect of VOC on the embryo culture system. Evidence 2, in vitro studies on the cultured cells. So here I will like to discuss about some kind of non-embryonic cells. As recently some interesting studies came out, and what some people what they're doing, some of the people working on the VOC research is to test the volatile organic compound, the gas phase, a special exposure device that allows close contact between the cultured cells and the VOC substances with a precise control of gas concentration used for this particular scenario. So these are one of the two studies that looked at this particular scenario that was published in the Nature group of scientific reports. In one, they looked at the cellular reactions to long-term VOC exposures on the lung cells, cultured lung cells. Another one was a proteomic study, and they looked at the oxidative damage and impairment of protein quality control system in keratinocytes exposed to volatile organic compounds cocktail. The one was a transcriptomic RNA-based studies, and another was a proteomic-based study. So this gives a kind of a lot of evidences and the impact of the VOCs on the culture cells or the human cells. So this is a kind of in vitro system that they developed for this study with a non-concentration and particular species of the VOCs were exposed to the cultured cells, and they looked at the effect of these cells on some of the molecular impact. So in one of the study, they looked at the formaldehyde at a particular concentration, a chronic exposure for 3 days, 0.1 and 0.5 ppm concentration, and they looked at the cellular response on the lung epithelial cells, and they found a significant enrichment in some of the distinct biological processes when they looked at the transcriptomic studies. And what they found also was the metabolism of specific compound classes like lipid biosynthesis, and some of these cell associated functions are affected by lower exposure levels, and some of the processes are affecting proliferation and even apoptosis or cell death that dominate the higher exposure like a 0.5 ppm. See, this is one of the evidence.
I have met him at Delhi airport, I think, once on conference.
Sir, please continue. I muted.
In the second study that I have shown in that scientific report is based on 5 different VOCs: hexane, toluene, acetaldehyde, formaldehyde, and acetone exposure to the keratinocytes. And they looked at the effect of these on human keratinocytes by proteomic study. And what they found, the interesting outcome was seen there. The proteasome, it is a major intracellular proteolytic system which is involved in a broad array of processes such as the cell cycle, cell death process, transcription, DNA repair, protein quality control, and antigen presentation is one of the target of using this particular VOCs. That is, they found with the proteomic analysis. And if you look at why this particular proteasome study using this system is interest to us as IVF or reproductive biology specialist, I also looked at the effect of the Wicked in a proteasome system in the human the embryos. And this particular study that came in a Japanese study that was published in Journal for Reproduction and Development in 2018. This title of the study shows the ubiquitin proteasome system modulate zygotic genome activation in the mouse embryo, and it influences full-term development. So we know that the activation of zygotic to maternal to zygotic genome transition happens in the mammalian systems when it is around 4 cell to maybe at the 8 cell to maybe more or less stage. So the impact of the VOCs on the proteome with this kind of studies also kind of give a critical thinking. We have to think critically how these VOCs are affecting maybe in our the embryo culture systems too. Now let us. These were the second evidence was on the cultured cells, not from our IVF scenario, but that gives an indication how it VOCs affect some of the cellular functions at the molecular level. Evidence 3, in vitro studies using the IVF system. One of the study that earlier studies that came out 7 years ago from a Dean Morbach's group when he was in the Mayo Clinic, and that was presented in one of the ASRM meeting, and the title was Interaction of Air Quality and the Culture Environment and the Role of Protein Concentration Oil Quality on effect of a particular VOC. What they have done is that they looked at a particular VOC known as acrolein. Acrolein is an airborne VOC with a widespread environmental prevalence produced during the lipid peroxidation, maybe burning of tobacco and liquid fuels. And in this study, he used an embryoscope or time-lapse system, and what he was done by using a mouse zygote, they cultured them to the hatching blastocyst, and the initial 24 hours of the 2PN zygotes were exposed to the acrolein, and they divided the cultures into 3 to 4 the different groups. In one of the group, they had only HTF media along with the TVA. They cultured with these particular without any proteins. They cultured these embryos. In another group, they cultured with HSA 1 milligram per ml, another 5 milligram per ml, another 1 milligram per ml HSA in the culture media along with peroxide containing oil. We know that peroxidation is one of the big problem in oil. Some of the manufacturers who doesn't do proper quality checks on the oil, and that's a big problem in IVF laboratories. So what they have seen is that from the study, the culture media that contains no HSA or only 1 milligram per ml HSA, the embryos were not developed. It is getting lysed at an early stage itself. On the blue color, what you're seeing is that the embryo cultured with HSA 5 milligram per ml. So that clearly shows that even a protein concentration in the culture media also plays an important role in alleviating or nullifying the effect of the VOCs present in your environment or embryo culture systems, or that is coming into your culture environment. And the final one of the study, in vitro study, that came from one of the PhD student in the IVI group. It was really an interesting study that they looked at the volatile organic compound. Here they used not the animal embryos, but the embryos that was discarded, or maybe that was given for the research purposes after the ethical committee approval and everything. So they recently published their studies on was the evaluation of effect of volatile organic compounds on human embryo development. And also another, they recently presented the effect of styrene over the human pre-implantation embryo development. And the endpoint of the study was the blastocyst development, aneuploidy, and chromosome aberrations by RACGH. And also they looked at the mitoscore level. One of the compounds they selected, even though they studied, I am discussing only a few compounds they studied here. The two important compounds, we know that benzene is one of the important component of the VOCs that might get into the IVF laboratory. Another is limonene on the human embryos that is donated for research. So they looked at three sets of the culture system. I think 400 embryos were used for this particular study. Day 3 embryos were thawed, good quality, maybe 8 to 10 cell day 3 embryo, maybe with less than 20% fragmentation or something like that. Quality embryos were thawed and cultured to the hatching blastocyst, and they took 3 concentration levels of these VOCs. One was the external concentration. What does that mean? External concentration of the VOCs is the concentration of this benzene that is present outside the IVF laboratory, outside the building. And the second set of experiment, they put the benzene at the concentration that is seen in the IVF laboratory, a good quality clean room IVF laboratory. And the third set of experiment, they put double the concentration that is found in the IVF laboratory. So they had 3 levels of concentration of this benzene and limonene exposure to the human embryos that they studied. And finally, they did a biopsy on the trophectoid biopsy on the developing blastocyst, and these biopsied cells were subjected to RACGH, and they looked at the aneuploidy rate and the chromosomal aberrations and anomalies, and also the mitoscore were also looked into. So this graph shows the effect of the benzene on the different concepts. What you see here, BE and BL and BDL, is the benzene external concentration, benzene at laboratory concentration, benzene at the double laboratory concentration, and this is the control. What you can see here, a reduction in many of these parameters like expanded blastocyst or the hatching blastocyst, hatched blastocyst compared to the control in the other 3 groups by using this benzene exposure. The same thing was also, even though not up to that level, but the limonene also given the similar kind of negative impact on the blastocyst, human blastocyst development. Some of them were really significant at a statistical level, like expanded blastocyst and also the hatching blastocyst at double concentration level. Then when they looked at the aneuploidy rate, the control group at a benzene exposure, if you look at this, the table here, the aneuploidy rate, you can see it is a 23, but the external exposure got a 38 here, laboratory concentration 42, and the double laboratory again 40. But limonene doesn't have that much effect, but maybe to some extent that was also responsible for the more aneuploidy All right. So benzene is significantly related to the increasing number of some of the chromosome errors in the set of 23 chromosomes. Then they looked at each chromosome level at a different concentration. What they found was that I think 85% of the chromosomes are affected, related chromosome, except C3 and 10. You can see that highlighted ones are affected by the benzene concentration, but not in the limonene group. So these particular chromosomes were significantly affected in that group. So that shows that these particular the studied volatile organic compounds have some kind of effect at the nuclear level when they are dissolved in the culture media and exposed to the human embryos. And on the other hand, despite that, limonene had significant effect over the development of the embryo, but it doesn't have a significant related effect on the production of chromosomal arrays. Then they looked at the mitose score in control group and benzene group. What you see here are the this could plot the diagram here. The mitose score in both groups. This is a limonene group, a benzene group, but it doesn't have much effect on the mitose score or mitochondrial DNA level. And the comparison between the whole control benzene limonene group did not have any significant effect between the mitochondrial level, neither between each specific treatment, exterior laboratory, double laboratory dose, and the control group. And this limonene, which is a very common IVF laboratory compound, has been tested in liposome model systems, and it has been demonstrated that it accumulates in the membranes, which causes a loss of membrane integrity and the dissipation of the proton motive forces, and as well as some terpenes. So we know that many of the functions of our embryos are related to the how they are well integrated with their the proton pump and the membrane related proteins, integrated proteins, and this also can metabolize through different pathways as well. So benzene is a lipophilic and hydrophobic and non-polar compound, and it can pass the cellular membrane because of the lipid bilayer that is present in the cells. And maybe the embryos are capable of activating some of these xenobiotics, leading to the production of reactive metabolites and ROS. Maybe that is the way. Still, that is not really clear, but many studies from non-embryonic cell culture and people say that it may be the cascade of reactions may be finally maybe by the oxidative stress that was initiated by this VOCs. Finally, I would like to just give insight into one of the one study that came out just 2 weeks ago from the MIT in USA, Massachusetts Institute of Technology. And I know that the next speaker is going to detail about what are the remediating systems for the VOCs in the IVF laboratory. So in this study, what they have done, they took 4 air cleaning systems or 4 air handling systems. And the operating technology was UVC and titanium oxide photocatalytic oxidation, along with maybe some kind of HEPA and activated carbon. Some had a photoelectric oxidation filter, some had a plasma technology. What they did, they exposed some particular amounts of toluene and limonene to these air cleaners, and they looked at whether in a closed chamber they exposed this toluene and limonene and passed it through this particular photocatalytic oxidation or this plasma based air cleaning system. And interestingly, what they found was the air cleaners themselves can be a source of organic gases. Like when oxidative degradation of VOCs was observed using this photocatalytic oxidation, but it was accompanied along with the formation of range of oxidation by products, including formaldehyde and other oxygenate. So one has to be very careful about when using this kind of a PCO-based or a plasma technology-based systems, because that itself can produce some kind of byproducts that may have to be taken care by a good quality, maybe the activated carbon or the potassium permanganate based system downstream of this PCO technology based, or maybe you can put it in the return duct so that your HU activated carbon can take care to some extent. So the Finally, these portable devices that are used in many laboratories, they measure, that photo TVOs in ppm. It may not be a good detection device because potentially maybe many genotoxic mutagenic VOCs cannot be detected by its low detection limit. It is recommended by the Cairo Consensus of 2018 that the IV laboratory should maintain a total VOC level of around less than 400 to 800 ppb that can be converted into 0.4 to 0.8 ppm. And Katie Orlow, who has done extensive studies, and one of her recent studies, including her 8 years of clinical outcome, evaluating the dynamic level of VOCs and viable and non-viable particulates within the ambient air 5F laboratory, that their study shows that VOC levels even far below 100 ppb even can affect the pre-implantation embryogenesis negatively. And in conclusion, the retrospective studies confirm the importance of clean room or VOC reduction methodology on IVF outcome. In vitro studies on individual VOCs on embryo quality and cellular or molecular functions are emerging from a difference the laboratories worldwide, some especially from the the IVF groups. We need more prospective studies, especially with the animal model and ART system, to give more insights on the effect of each individual VOCs that is present in the IVF laboratory. And I was to give more emphasis and to be given on the type and model of VOCs and the handling equipment and the system that we use, and also VOC monitoring systems so that we use employed in the IVF laboratory. Thank you very much.
Great. Thank you, Dr. Alex. That was a very comprehensive and lucid presentation. What we already knew was just a tip of iceberg, but what you explained and shown with your all the slides, it is pertinent to think over again and again and do and implement the remedies that probably can eliminate the VOC levels or substantially reduce the VOC levels to the permissible range. Something which was very alarming was your last slide, that even these devices which are being used in our laboratories may in fact be generating VOCs. And I mean, I have heard maybe the anecdotal reports from our colleagues that once they installed some kind of system in their laboratories, their fertilization rate or their live birth rates or the clinical pregnancy rates actually have gone down. So this could be very alarming to all of us, and we have to look at this particular aspect in a different point of view. So thank you very much, and I believe everyone has enjoyed your very beautiful presentation. I open the house for the discussion. I don't see any question here, Amit, but even I invite all my fellow moderators and speakers who are on the panel and in the webinar rooms. Fortunately, we
Yes.
have Lars also among us.
Yeah, exactly.
Yes.
Yeah.
Welcome, Dr. Jafar Ali.
I think it was very informal and nice, and Alice can always find those small things that is helping me, because I'm involved in this. I'm building clinics that are VOC free by selection of materials and so on, and it's taking off big time now with COVID, because it's also take away COVID. So we have a lot of installation in hospitals, but I will focus on the clinics. Yeah, we have known this, the VOCs affecting this since, in the beginning or the end of 90s by Cohen et al. But there's a lot of publications that people haven't looked at that much, and I didn't believe much in this. I was very, very skeptical when I saw the results when you put in this live air ventilation, and it increased the pregnancy significantly. And the other thing is, as was mentioned at the end here, there are many that are trying now because of this COVID to say they have the solution for it, what they haven't tested it properly, and the byproducts are the killers actually. And we see also in studies with different time-lapse machines that we put in a special ventilation system that we actually get more Blastocyst and higher pregnancies. And in those that have variations a lot during the years, when you have a cold air that blocks the things to go off, like in Delhi, I would recommend that you all have special ventilation systems, and it should be, it's the base for everything. So when we build, we always have the embryo lab covered, no general ventilation system at all. And then you see less variations. And this has also been published before this COVID in 2020, but Zygote hospital study, there where they have the normal ventilation, then they changed the part of that ventilation to some other areas, and they put in the whole live air ventilation, and the viruses went down almost to 0. And the people didn't get infections, and they were home quicker. So it's not only for IF. So it's very important that you eliminate all these byproducts also. So now we have built also in UK, Estonia, Sweden, and the key opinion leaders from ESHRE are also installing it. So it's a lot of things going on now. And I think it's really sad to see that people have reacted so late when we have known this for a long time. And I urge everyone that have an IVF clinic to start thinking about the environment. But one thing I also see is that you do not service your laugh benches in the class 2 in a good way. And those filters there, they can generate also VOCs that get down into your cultures. And that causes a lot of problems. And there's some people think that if you have oil, there's no VOCs. That's wrong, totally wrong. They are taken up in milliseconds. So when you prepare also time-lapse cultures, if you're using the wrong tips when you're loading the media or loading the embryos, you have destroyed the cultures already. So your selection of disposables is quite important. So don't save on small amounts that can actually kill off your whole system. Even if you have a really good ventilation system, you are doing something wrong with your handling. And I thank Alex again.
Thank you.
I'm really pleased to hear all this. And you know, we're there for you if you need anything. And we're going to have a webinar on the 14th of December. But it is for invited only. But anyone that likes to be in this webinar where we will talk about this and how you can do. You can also do retrofit. You can send an email to me, and Alex, he has the my email anyway. So thank you again. I have to go to another meeting, and God bless all of you.
Thank you, Lars.
All Sweden.
Thank you so much, Dr.
Thank you for your comments. And Dr. Yona wants to ask some question. Please unmute yourself, Dr. Yeah, perfect.
Thank you very much, Alex, for a wonderful talk. You have made for me a very high limit now, you know. Anyway, I was thinking during your talk, do you think it is possible that the patients that are coming are already affected by the VOCs outdoors, the lab? Because we always check ourselves, and I will talk about it now, but we always check ourselves and we do our best, and we put and we try to reduce the VOCs for really minimal values, but then you don't get you don't get embryos, you don't get precipitation embryos, and then the development is stopped. You know, after thinking about it, and I don't know if you remember my talk about the temperature, I'm starting to think that this is an intrinsic damage already in the gametes. What do you think about it?
Yeah, when we talk about these IVF for laboratory culture conditions, maybe the multiple parameters maybe can contribute together to the effect of the VOC. What we have seen is that, especially with the monitoring systems, when you bring down the temperature in the IVF laboratory, you can see some kind of a reduction in the monitor in the VOC level. So definitely the VOC level may emanate or release from the your surfaces when the temperature is more, and maybe if the temperature is not properly maintained, I think that is also maybe particular kind of different reactions might can happen from especially when IVF laboratories not only handle normal type of patients, even that is a study from Sandro Istos, even the male factor patients, so they have seen a reduction in their outcome, especially when the sperm quality and the things were bad. So I think that is what you wanted to discuss, or if I am clear.
Can I comment it?
You are muted.
Yona?
You are muted, Dr. Yona. Yeah, perfect.
Sorry. I was thinking, Alex, you were talking about very, very important things, and that is our discussion today. And you know, let's imagine that the lab is empty of VOCs. There is no VOCs in the lab. Okay, we've done the best, but still, and I'm not talking about genetics. Still, you will get unfertilized oocytes. You will get a slow development of embryos. Don't you think that we are starting with a material that was affected outside of the lab, outside of the unit? They are coming affected already, probably also by VOCs, depends on the area, depends where they are living, you know. That's what I was thinking during your talk.
I understand. Yes. Yeah, I think that's, I think it is said that there are more than 200 variables in the IVF laboratory. You can say IVF, the VOC is only one of the variable, one of the major variable. But if you can control that, as you said, if you can make it less than 1 ppb or something like that, then you can concentrate on the other, this consistency if you can make, you know, as you said, that's right. All the contact materials, how you practice the thing, what kind of the maintenance of physical parameters are maintained, all this can affect the final outcome. Absolutely right.
Unfortunately, Dr. Yona, we are exposed to so many chemicals and surfactants and pesticides and insecticides, all sorts of chemicals, the pollutants, the exhausts from the motor vehicles and the factories. So it's very difficult to control those things. I mean, almost impossible. We are all exposed to those things. So yeah,
Sir,
they are definitely going to.
We are running out of time.
Oh, sorry.
Can we proceed with the next lecture?
All right. So we'll continue discussing all those things if we get the time.
Can I get a short comment?
Yes.
Seconds? Okay. No, I'll just say, but Yona, you know that high age and male factor, they are affected already. And of course, but when you have installed this ventilation system, you look at them, they also have a better chance. So it's definitely something to do with the environment. And those they are using clean room, they are not really clean room. I don't know how many audits I've done in how they work. They think they don't have to take action against them. People are running in and out with outer clothes, and they're overusing detergents. That doesn't help. Doesn't help if you have a good ventilation system. So with this, I leave you. Thank you. Bye.
Thank you. Thank you so much, Shukla sir. Thank you so much, Alexa, for that wonderful lecture on VOCs. So taking forward the session, I would like to introduce the next moderator, Dr. Vedprakash sir. The sir is working as a lab director at Southern Faculty at Delhi. Sir, over to you.
Thank you, Sanket, for wonderful talk, for wonderful introduction, sorry. And from
Just
Dr.
share my
Alex.
screen.
Hello.
Yes, sir.
I have to share my screen now. Just a minute, please.
Yes.
So first we heard from Dr. Alex how it is actually hampered the laboratory environment. Now Dr. Yona Brak is here. She is going to speak on VOC in lab, a serious headache now, how to get rid of it. And Dr. Yona Brak is a well-known personality in IVF segment, and she is graduated with MSc and PhD degree. Both these are towards the MSc and PhD degree dealt with in vitro maturation of mammalian oocytes. Dr. Brak established many IVF programs worldwide as a part of a team in 1984, the Tel Aviv Medical Center, where she operated the IVF lab as a director for 12 years. And in addition, it established own and led the InviMed clinics in Poland. Throughout her career, Dr. Yona Brak has trained many embryologists worldwide. In 1996, established and became a lecturer and the clinical director of MSc program of gametology and embryology in Bar Ilan University, Israel. Member of Faculty Scientific Advisory Board and lecturer of MSc course for clinical embryology in Dunway University, Krem, Austria, an international program of clinical embryology in cooperation with Bonhall, UK, and Alpha Scientist in reproductive medicine. In 1996, she was elected by members of Alpha Scientist in reproductive medicine as an executive board member, as a treasurer in 1999, vice president in 2001 to 2004. In Israel, she is a member of National Advisory Committee of Gynecology, Embryology, and Neonatology, owner and director of Dr. Yona Brak Laboratories Limited. Dr. Brak is teaching referee and a member in the editorial board of online journal Women's Health and Gynecology, supervising, lecturing, and creating new IVF unit. An active scientist, she is collaborating with leading scientists and physicians in the field of IVF, publishing many works in the ART field, such as being a pioneer for HA as a replacement for PVP in ICSI, IMSI, human oocyte vitrification in closed system, freeze-dried sperm, and more. Over to Dr. Yona Brak.
Ma'am, you need to unmute yourself. Yeah.
Sure. You want to continue? Yes.
You know, ma'am, you can start sharing the screen.
Okay. Just a minute, I'm trying to share it, okay?
Yeah, ma'am.
Okay, okay. Yeah. Yeah. Share screen. Do you see my screen?
Yes, ma'am, we can see your screen. Please go to the first slide, ma'am. Your last slide is visible. Yeah, please drag the cursor over there in the right answer. Yeah. You can use arrows. Right. Ma'am, please make it to slideshow.
Okay.
Yeah.
Thank you. Okay, so first of all, thank you so much for the invitation. I was very excited to meet you on Zoom. I would like to thank so much Dr. Raul. He considered himself to be my student, but I think we are learning from each other. I would like to thank Dr. Alex, Dr. Parkash, and Dr. Sanjay, and all the others that I did not mention. And I really miss you guys all. And we hope, and thank you, Dr. Parkash, for the nice introduction. I think everything was before the COVID, wasn't it? Anyways, my talk today will be Voc'S in the IVF lab. I took out the headache because, you know, I don't like negative things. But my talk will be on Voc'S in the IVF lab. Can we get rid of it? Okay. As scientists, our enormous challenge in the field of art, and more specific in the field of IVF, is to find the optimal environmental conditions in vitro for the gametes and the developing embryo. Moreover, that this environment should be, as much as possible, similar to the physiological conditions, or in other words, we should mimic the natural environment of the gametes. The environment should be optimal for the sperm, it should be optimal for the oocyte, optimal for the process of fertilization, and we should supply optimal conditions for the pre-embryos to cleave and reach the blastocyst stage, when the main goal is implantation, of course. The IVF laboratory procedures are a successful application of scientific knowledge of handling gametes and early developing embryos in culture. In fact, our routine work is a translation of our scientific data into the working protocols. When you start a new IVF program, let's say that we started from the beginning, we would like to choose a location that will be a quiet area and will be with clean environment, and not close to industrial areas or busy roads. But this is rarely happens. Generally, we are starting when we have a building, or we have an operated IVF unit, so we have to take the most of it. Even though an IVF laboratory may on the surface be clinically sterile, it might be still contaminated by VOCs. What are those VOCs? VOCs are volatile, hydrocarbon-based organic compounds which have a high vapor pressure at room temperature. There are many different VOCs that can be found in an IVF lab. For instance, formaldehyde, alcohol, isopropanol, hydrocarbons such as xylene, refrigerant compounds, and much more. Let's talk about the ambient air quality. The procedures in an IVF lab require a stable culture environment where ambient air quality plays a crucial role. Existing data indicate that both particulate matter and chemical pollution in the lab adversely affect IVF results. Thus, efforts have been invested to optimizing the embryology laboratory environment and to minimize the possible adverse effect of ambient air on the IVF outcomes. When we measure the VOCs, the results of the measurements should give a better reflect on the quality of the air indoors. Else, the measurement should give the genotoxicity potential of the biochemical interaction between the gametes or the embryos or both and the contaminants. So first step is actually the measurement of the VOCs. In the IVF laboratory, VOCs levels are generally measured using portable reading instruments with VOCs probes. The samples are taking place for short and long-term sampling, like hours or days. These instruments determine the total VOCs concentration, which means the total concentration of all VOCs in a defined measuring range, but we don't know who are they. The measurements are expressed in parts per million ppm or parts per billion. Studies have reported that increased level of VOCs were related with a decrease in clinical pregnancy rates. However, the specific thresholds according to the type of VOC remain unknown, except for aldehydes, which is the limit between 80 to 100 ppb. In the IVF laboratory, it would be more appropriate to perform VOCs measurement with instruments that providing readings in ppb. The values in ppb units give us the possibility to detect very slight changes in the air. So, is it possible to get rid of VOCs? Various air cleaning technologies exist with variable efficiency to remove particulates and VOCs. Some history, and I remember that on 1997, it was like a revolution. Jacques Cohen and Brian Dale investigated the effect of chemical contamination on IVF outcomes in different settings. In their current study, a new IVF lab was built by Brian Dale in an industrial area above one of the most busiest streets in Naples in southern Italy. And you can imagine what is a busy street in Naples. When they started their IVF activity, there was a decrease in pregnancy rate, which it was reported in this paper. They installed a pump to push air through a water-filtered gas bottle before it entered the incubator. Pregnancy rates increased again. Then they installed filters. The filters contained solid carbon and potassium in the IVF lab to remove adhesive and paint smells and other pollutants. After 16 months of the installation, the implantation rate increased from 22 to 36%, and it was recorded in a cohort of 1,400 patients. Unfortunately, the levels of the VOCs were not precisely evaluated. The filter, means the CODA filter, which they built was to reduce the VOCs, aldehydes, bacteria, fungal spores, and all particulate matter. This filter contained also HEPA, a high efficiency particulate air, with spores of 0.3 micron to remove particulate matter. Now, what else except air in the lab and except the pollution from outside? What else in the lab might be a source for VOCs? What can we do with it? So first we have the incubators and the compressed medical gases. Between the incubator and the compressed medical gases should be a filter like the Coda or some others which has from other companies with the same idea, this might avoid a high level of the VOCs. Now, inside the room, there should be a filter, not only HEPA filter, but also other filters like carbon and other materials for the cleaning supplies, for avoiding the VOCs from monitors, microscopes, and furniture. So it means filter and filters and filters. There might be VOCs that are that will be accumulated in the IVF lab from next door cabinets. Then we should use filter and positive pressure also in the main lab. The positive pressure creates an air pressure differential between next door rooms, so the particulate matters and VOCs are carried away, whereas the newly filtered air diluted the remaining particles in VOCs. Now it's going to be the laboratory personnel. Alex was showing it. He was talking about cosmetics. I know that there are many units that a personnel cannot wear deo or nail polish or perfume. So here I would like to put my personal point of view. During my experience, you know, I started IVF 2.5 years ago, but you know, I never gave up nail polish. Here I'm going to be a non-conformist, or actually in our religion, it is heretic. And don't go afterwards. I said, Dr. Yona Barak said it's allowed. I would like to explain it to you. It started many years ago when I visited the one lab in New York for troubleshooting. They've got no fertilization. And when I got in, the embryologist was very dedicated for his work. Really, he was thinking about every step. But after half an hour with him, I almost fainted. So I asked him to open up the air condition, but he said, no, he keeps 37 degrees. You know, in that time, we had these big incubators. And when you get these big incubators, so you have the way from the bench to the incubator. And I said to myself, after I finished to give my point of view there, I told him, look, we are only human beings. We are very dedicated to our work, but we should be able to work happily during the day, because sometimes we are spending there much more time than we are spending at our home. So 37 degrees for you, it's impossible. You will not be able to work properly. You cannot think properly. You are very depressed because of temperature, and we changed it. He has got fertilization, pregnancy, everybody was happy. But this made me think, okay? And I was thinking, I was always allowing my personnel to wear deo. We just said, okay, we are going to get a organic one, because now today it's not a problem. There are varieties based on oil and this kind of thing. You know, if you also put perfume only very slightly in the pulse points of your body, and you are not making aerosols, you know, behind your face or whatever, then I think if you are careful and you are monitoring your lab with the instruments to measure the VOC level, it might be fine. And you're happy and everybody happy. You don't have to, you know, it's not, but you don't have to wear smells that are not nice to you or to your colleagues during the day. And we are working in very hot countries like in Israel. Now today it's 25 degrees, but it's winter. In the summer, it's just impossible not to do all this. So this is my point of view, and I'm going to show you the way, I'm going to explain you the way I think you might do it. And remember, carefully, if you didn't do it until today, you have to do it carefully, okay? So how can we change the habit of the personnel in the lab? First of all, we should do it, of course, in a stepwise manner, like we do every change in our scientific work. If you want to make the change, you decide about one person at a time, okay? You measure the VOCs on a daily basis before you make the change, at least twice a day. And then you measure VOCs on a daily basis, twice a day, for a period of time, let's say 1 month or more, okay? You correlate the outcome with the level of VOCs at least 1 month, depends upon number of patients. If you don't have so much patients, you have to continue to do it for another period of time. When there is no change, or sometimes better, you know, if we are working, we are happier and we feel better, so what outcome might be better. So then you start with another colleague, with another friend from your personnel. Okay, this is my point of view, and good luck. One other thing I want to tell you, which I forgot, about the causes of the plasticware, of the disposables that we are using. I learned it from, you know, it's like going from one person to the other, but I learned it from Brian Day. The plasticware has a huge amount of VOCs into, and then what you have to do is to take it out of the package a day or two before you use it. You can put it in the bench and leave it there naked, without the plastic, without the covers, and then only then use it. And then you will have plasticware with very low levels of VOCs. So what is my take-home message? Can we get rid of VOCs in the Harghese lab? I think we have to keep trying. We can't get rid of all the VOCs, but we should keep trying and reduce the VOCs to minimum values with no adverse effect on embryo development or pregnancy rate, by using the proper means that we have, filtration and negative pressure. Thank you very much for your attention.
Thank you, Dr. Yuna, for wonderful talk. Actually, I think with your experience, so many things we learned about that, how to get rid of VOCs. But of course, floor is open for questions. If there is any question, please, you can ask. Sanjay sir, do you want to ask something?
Yes, please.
Yes.
So, very simple observations when I visit to some other places, some other laboratories. I have seen a few centers where they have a separate incubator, and it is always full with the stacks of disposables, especially the culture dishes, to keep them warm. And once they take out a few dishes, they again replenish the incubator, and it is always full. So I wonder whether these disposables, these plasticware, because they are all the time they are warm. So do they release VOCs inside the incubator? And in fact, they are doing more harm than the good.
Well, Dr. Sandra, thank you very much for the question. So I told you during my talk that I learned it from Bindale many years ago. He showed it to me, you know, with measuring. What happens is that if you keep it in the plastic, you keep also the VOCs of the plastic, you keep the pyrogens over there. But if you take it out and you put it on the bench, even if you warm it up, these are not huge amount, but it goes up with the filter, with the air of the bench. And then when you start using it, I would not do it less than 48 hours. But when you start using it, the level of the VOCs should be very, very low. I think, I don't remember, but it should be really very low and a level that you can use safely in the lab.
Yeah, but I mean, it's fine if you are using them on the bench, but if you are keeping them in a closed chamber like incubator, you are in fact accumulating VOCs inside the incubator.
But it's the point. You should put them in the incubator after there was evaporation of the VOCs from the plastic. The empty dishes before using, okay, you keep them on the bench even if they are warming, and so the pyrogens are evaporating from the dishes, okay. And if you put them in the incubator, first of all, you should have a filter in the incubator. I think the new ones, they've got a filter on their own, and the older ones, you should put a filter, okay. So the amount of the VOCs that will be released are not very high, and it will be absorbed by the filter.
True.
Okay? Is that okay? That was your question? Did I understand it okay?
Yes, sort of.
Okay.
Anyways, thank you very much. Another thing is like, it's not a question but a comment, like the practice that we have in our laboratories that we implement, and we purchase some inline filters and the VOC filters, and we forget to change them. So they keep on accumulating or keep on absorbing the VOCs, and later on with the leaching effect, they keep on releasing the VOCs in the laboratories. And same stands true for the inline filters.
So you have to change it
Yes.
very quickly. You know, I would recommend to change it. You're right, but I would recommend to change it before the time that is recommended by the company. You should do it in your own lab if you have the possibility. Not you, but this is my
Yes,
point.
everyone. Yeah, everyone.
Okay. My suggestion is that if you have the possibility to measure, you start to see when the VOCs are rising, okay? And then when the level is rising, then you have to change, like to say, I term it as a clean table. You change everything, all the filters, everything, and you start again.
Perfect. Perfect. Thank you. Thank you very much.
There is one question that does that inline filter really give a good effect on the embryogenesis?
I'm
Inline
sorry.
filter. Does inline filter really help in good embryogenesis? Inline filter. I'm asking about inline filter.
Okay. So what is your question? I'm sorry, I have some problems.
So there is one question that does it really help? Inline filter, does it really help in embryogenesis, better embryogenesis or better success rate in pregnancy?
If the question, if it helps, yes, I think it helps a lot. You know, when we had these big incubators, we used to put two filters. You know, there is a place for one filter, but we used to cut the wire and to put another one, because I think they've got a very crucial task in the lab, and even if you are using the gas, which is a high medical level, very clean, you should take care that the inline filters will be, first of all, they will be in between, and secondly, that you will change it frequently, because when you send it to a lab to check the levels of the VOCs inside, you will find a lot after a short while.
Dr. Vijay Charul want to ask something. Dr. Vijay, please.
Yeah. I just wanted to pick up this particular topic and talk about a laboratory person just farts in the room when he is working can rise VOC levels in ppbs. How will we tackle this? And how can we stop a person from farting?
You have to be responsible for your
Good. Great.
Okay, I think we are running short of time.
Out of time, sir. Yeah. Thank you so much, Dr. Yona, for that wonderful lecture. Next, we'll be heading to the panel discussion, finding out what is more important in IVF culture conditions. So I'd like to introduce the moderators first. Vitro, can you please share the CVs? Yes, first we have a dear friend of mine, Dr. Sahil Kandari. She is MSc and a PhD in reproductive biology, and also PGCRT in genetics and certification in clinical embryology from Cleveland Clinic, USA, and a PGT and PGS embryo biopsy certification from Embryo Tools, Spain, and also fertility preservation PG certification, and also from ASRM. And she's affiliated with many things, and from starting from research scholar from Ronin Institute, USA, Chief Scientific Officer, Cellshow Biotech and Research Center, Mumbai, India, Consultant Embryologist and Laboratory Director of IVF Centers across India, Director of Reprogenics LLP, Advisory Panel Embryonics AI Private Limited, Israel, India, Advisory Panel Infertility Division, Shield Healthcare Private Limited. Welcome, Dr. Sayali. And next we have is Dr. Gaurav Kant. Gaurav is a co-convener of SAG Andrology, IFS 2022-2022, and also co-convener for SAG Embryology, IFS 2018-2020. Currently is working as a senior embryologist at Akanksha IVF Center, and he's supposed to be the first Indian embryologist to be certified by the both prestigious societies, international societies, ESRM as well as ESTRE, and also is certified by IFS and Global Fertility Academy. And he has presented around 11 international presentations in ASRM, ESTRE, and IFFS. And also he has obtained his Blastocyst biopsy and cryopreservation training from Barcelona, Spain. Welcome, Dr. Gaurav. So over to you.
Hello.
Yes, Ali, you're audible.
Hi. Is Gaurav there?
Yes, he's there. Gaurav, you can unmute yourself.
Okay. Can you see my screen?
Yes.
Fine. Sayali, you want to start?
Sure. So,
okay.
Yeah, go ahead.
Okay. So today, me and Sayali, my moderator for the session, we are basically going to discuss about the factors affecting the IVF culture media. And we are not the moderators here. We are basically the seekers here. The reason being is we have extreme talented and well-renowned panelists with us. Sorry, the first one is the Line Nice, and she is the laboratory manager at Care Northampton. She leads a team of 10 scientists there, and just a minute. Okay, she leads a team of 10 scientists there, and she is constantly improving results, quality monitoring, and innovations. Next is my mentor, Dr. Brigadier R.K. Sharma. I have learned a lot of things from him. He has plethora of knowledge. Whenever you go to him, he'll teach you from the basic, from the scratch to the zenith. He knows everything. So welcome to you, Dr. Brigadier Sharma. And he is right now the director of Mao Fertility Center. And he is the ex-director, HOD, Institute of Reproductive Medicine and IVF Center, Primus Hospital. He was the founder director of ART Center at Army Hospital, RNR. And he is an advisor of lots of units in India. Next is Dr. Charudat Joshi, a well-renowned embryologist from Kashmir to Kanyakumari. Everybody knows him. He is MSc and PhD and done his CRT in Belgium, and he has immense experience in embryology, immense experience of ICSI, immense experience of IVF, semen preparation. He knows everything, whatever is happening in the IVF lab. Next is my dear sir, Dr. Vijay Kumar Chellur. He is a very genius man, and I always compare him with the razor. He's very sharp. He knows the basics. If you talk to him, he'll talk about the microns. He'll talk about the mitochondria size. He'll talk about the atoms, and he has a very in-depth knowledge about the subject. And it's always a pleasure having him in the panel and discussing things with him. Unfortunately, Dr. Kersi is not here. Next, we have Dr. Charulata Chatterjee. She is a beauty with the brain, and she is right now the scientific head and consultant embryologist at 49 Fertility Centers, Secunderabad.
Gaurav, sorry to interrupt you. Dr. Kersi is already here, I think.
There, yeah.
I can see
He
him.
has joined. Acha. He apologized.
Yeah.
I'll introduce him. Don't worry.
Dr. Charu is not here.
Dr. Charu is not here.
Yeah. Dr. Charu.
Okay. Then the Dr. Kersi is here. Dr. Kersi is the MSc and PhD in reproductive endocrinology. He has 18 publications in Indian and foreign journals. He's a teacher of teachers. He knows lots of things, and he is right now the founder director of Embryology Academy for Research and Training. He's a consultant freelancer embryologist, and he believes in application support specialist, ART, and embryology and cryobiology. Welcome to you, Dr. Kersi Avari. So
we'd like to welcome all our panelists. We are very honored to have you and such a plethora of experience together in one Zoom call. So Gaurav has created a beautiful storyline for us. So let's start.
Yes, so we have talked a lot about VOCs and VOCs and ROS. So the main thing what we are going to talk about is what affects the embryo culture system. So here this story starts. We have a clinician, her name is Elma, and Elma has an embryologist, and his name is Chintu. Chintu, we all know for the foreign faculty, Chintu means an immature guy, right? And Chintu has a friend, and whose name is Chatur, and Chatur is an experienced embryologist like our faculty, and he knows everything from bottom to top, whatever is happening in the world about IVF, Chatur knows it. And Chintu is an immature guy. So what happens is, they both decided to open IVF center. They discussed everything, whatever is there in the culture system. They talked about the oil overlay, culture media, drop size, gases, QA, QC, whatever in coming in contact with the culture system. They discussed everything and opened this IVF lab. They did the first pickup. They retrieved 5 oocytes, they did ICSI, 2 fertilized, and what they have is this: a very poor C-grade embryos with lots of fragmentations. So, as usual, what can happen? The Elma started screaming on the Chintu. What is happening, Chintu? Why this? I have given you 5 beautiful oocytes. Why there was a lower fertilization rate, and why you created this poor oocytes? Chintu started crying. Chintu has no solution because Chintu is immature. Chintu has only one solution: to ask Chatur. And Chatur suggested, did you check the other parameters? There are lots of factors which can be there. Did you check the temperature, pH, humidity? So, Sally, you want to take on from here?
Sure. So as we are following up the story, now Chatur has come up to Chintu and saying, dude, calm down a bit. We are going to discuss, and we are going to ask our panelists, who are all Chaturs, all experienced embryologists. And so the first point, temperature. What is the optimal temperature according to the panelists? How do we measure it? What options do we have? And what are the tips and tricks that you practically use in the laboratory at different points to maintain the system? That would be our first set of questions. So Gaurav, who do we give the questions to first?
Anyone can start. I think Vijay sir is here. Vijay sir, please.
Okay. The optimal temperature is between 36.5 degrees Celsius to 37.5 degrees Celsius in the media, not at the table temperature.
Okay.
And the best way to measure is you keep an empty dish with micro droplets under oil, whichever is your culture condition like. If you have got an open culture dish, then you practice with an open culture dish. Keep a sensitive PT1000 probe into the media droplet and try to measure the temperature and try to note down over a period of time what is the fluctuations with your set temperature on your heated stage and other things.
Okay, that's nice.
On a blind thing, not on the gamut this one. So you have to standardize on a blank dish with your mimicking your culture conditions and try to measure the temperature of the media droplet or the media rather than the table temperature.
I agree that that's very important, but there's actually a way of measuring within the dish. So there's something available called thermobuttons, and the thermobuttons you can put into a dish with the oil and then download their monitoring.
Data over a period of time.
Over a period of time.
Yes.
So, and you can use them for QCing equipment, you can use them for QCing your ICSI rig, whatever, wherever you need to check the temperature within your dish. And because you don't have any wires and because you don't have any leads, then you don't have the problems of the positioning of the probes and things like that. So I would certainly recommend looking at thermobuttons.
And a word of caution, no matter, even if you are confirmed that the temperature over a period of time is going to fluctuate between only this much, to keep the fluctuations to the minimal, try to expose it as minimal as possible.
Mm-hmm.
Any other comments, sir? Like the distance you felt?
Well, that's where something like the embryo scope is so important, because then you have uninterrupted culture conditions. And in fact, we've also now moved to a do not disturb policy. So after checking fertilization, we have stopped doing the embryo checks on a daily basis for standard incubation. And we're seeing an increase in blastocyst formation and the utilization rate.
Yeah, I would like to add here one more thing, that we have to keep in mind about the ambient temperature of the lab also, because that can also affect the temperature of your surfaces and temperature of your working dish and everything in the lab. So that also has to be taken into consideration when we are doing calibration for our temperatures of the laminar flows or incubator or dishes for the temperature.
So Charu sir, for the audience, I want to know, the people want to know how often we should check the temperature in the lab. How often we should calibrate?
I think it should be a daily routine. There should be a constant monitor of room temperature installed in the lab, and it should be an online process. Always you have to check with the temperature of the lab.
With the lab, and about the instruments like the incubator, like the surface of the ICSI dish and the microscope stages, how often you should do this?
I think that you can make an standard procedure as per your convenience and as per your working conditions in the lab. That can be done on weekly basis. Temperature of the surfaces can be checked daily, because suppose, for example, laminar flow, it has to be kept in mind that everything we are doing in laminar flow, inside laminar flow, so the temperature really matters over there. Incubator, you always have a temperature display. So once it is calibrated and once everything is done, I don't think there is a daily need of checking temperature in the incubator. Maybe once a week is good enough.
I would like to make a comment.
Oh,
Is
yeah.
it possible?
Yes.
Okay.
We constantly monitor our incubators 24/7, and we daily look at the minimum and maximum temperatures, because sometimes if you have a lot of door openings, then you will find that you have a big fluctuation in your temperature in the incubator. So we actually set KPIs for our incubators daily, and if we see the temperatures fluctuating because of door openings, then we look at what the volume of the work going through that incubator is to try and minimize it.
So do you use an online monitoring system all the time in your laboratory versus the thermobalance, which will only give you information later?
May I make a comment? It's
Sure.
Yona Bar.
Yes, ma'am, please.
Okay, so I would like to remind us that temperature starts in the pickup time, and I would suggest to leave in every pickup, not to leave it to make it fresh in each pickup. A test tube with some water to check the temperature of the warm plate or the collector of the pickup tubes. I think, like Dr. Sharma said before, it should be an empty dish on the bench and an empty dish in the incubator. Although I agree with Dr. Lin that we should make some kind of checkups for the incubator, but I would suggest before each pickup that it should be like a routine to check temperature, because here I see that the variance between 36.6 to 37.1 is a kind of half a degree is, to my opinion, a little bit high. I would make it like 36.8 to 37.1 or whatever, but not more than 0.2 to 3 degrees. Although, you know, it might vary, but these are the points that are very important. Pickup time, incubator, working on the bench, and each pickup a new one.
Okay, all right. Because we just wanted your opinion on, so Gaurav, we have those two papers regarding temperature. One which says that the circadian rhythm, which is ranging from 36.6 to 37.1. This paper is by Ronnie Jansen of Brussels. So he mentions how 37.1 is far better for embryos than 36.6. So like Dr. Yona Brak says, maybe we should have a very thin line of temperature if it should be monitored. But like Ms. Lynn said, the online monitoring is the only option, because from the scenario we come in Southeast Asia, in India, it's not possible for us to put an online monitoring system in every laboratory. Every laboratory does not invest in such a thing. So, like Dr. Yanabarak said, what do you both think, and what do the panelists think? How do we really do it in our circumstances, make it economically viable, but still we want to get that kind of quality in the laboratory and maintain temperatures in a thin line? It would be our question.
Well, we have a startup protocol every morning where we check the temperature of the benches, we check the temperature of the hot blocks, whatever. So at least we know before we start work every day that everything's working and it's in the right range. And that's fairly simple. That just takes half an hour, but it only tells you that everything's working at the beginning of the day. I don't know what other people do.
Could we have any other comments from the panel? Thank you, Mr. If we have any other comments, we have such an experience that Dr. Charu sir,
Yeah.
R.K. Sharma sir hasn't spoken a word. Dr. Charu, we would like your comment.
I think in our case, we can always monitor that temperature monitoring should not be a big issue because we have very good thermometers which is available. More important thing which I feel is that just having a good thermometer is not going to work. You need to get it calibrated from some standard organization, and you always keep on standardizing the instrument. Then only we come to the real temperature readings. Like what is the error and how much 0.1 degree or 0.2 degree here and there. So I think calibrated instrument, it's very easy to get the calibration done. And we should use this calibrated instrument in the lab. Particularly for thermometer, I think it's not a very big thing right now. We can have good thermometers, very reasonable cost.
Okay, all right. Thank you for your comment. Gaurav, should we move on to? Yeah. There are so many factors.
You want to comment about it? Okay. Okay, so now we are done with the first case, and whatever has happened with the Chintu by the Elma, he stopped crying and they decided to do the second case. In the second case, Elma retrieved 8 mature oocyte, and Chintu was able to fertilize only 4. And again, what Chintu created is this: 4 poor quality oocyte embryos, probably C-grade again. Elma lost her temper now. She started screaming on Chintu, and Chintu has nothing to do except of going back to Chatur. Chatur said, okay, Chintu, we have talked about temperature. We have talked about the pH. Did you check the air quality? What happened?
We didn't.
So, so now my esteemed panelists, I want to know that we have talked about the VOCs in the first 2 talks. How you manage it? I want to know what are the key points from each of one of you. That what is the most important thing in your lab? I want to start with Brigadier Sharma sir, if he is here.
Yeah. The thing is, see, over the years, when you are working in an IVF laboratory, and you walk in the morning, and you just take 1 or 2 deep breaths, you will know, yes, there is some problem. Some mold somewhere growing, as a embryologist, you all must have got experience by now. You walk into the laboratory and you can smell it actually, with experience. Yes, there is something wrong. There's some pollutant which has entered into your laboratory. To see around from what is the source of that. Maybe a new building is coming up next door, or new halwai shop has come next to your clinic or something like that. And then once you have seen outside, you already know that your building which you had created and what type of the walls you had, whether you had granite walls or you had this modular labs and all nowadays. Now what is happening, especially in India, what I feel is that no walls are totally seepage free. And if you have a say modular type of lab, what is happening behind that modular lab in the wall, you will never know. And all the electrical points which are fixed on that modular lab, they are not airtight. So whatever the fungus and everything which is going outside in between the wall and your modular lab material, it keeps on leaking into it. So if you have to check, for VOCs, and you'll find around the electrical points is the maximum concentration of VOCs over there. So that is, one knows there's something is wrong over there. So from planning your IVF lab and then, managing it so that you do not get this VOCs inside. So one has to be a little careful, and with experience, one would know, and then one can, deal with this VOCs accordingly.
Right. Dr. Lin, anything from your side that we want to talk about the clean room technology, that we should have the rotations, best HEPA filters, we should have the alpha filters. Anything else that you want to tell from your own experience that this is something which we all should do?
The coda filters are really, really good, and it's worth investing in a coda filter even if you've not got anything else. But every lab is different, and it just depends on what you've got available to you and what facilities there are around you. But certainly the coda filters are a good place to start, just for cleaning the
Sharu sir, I have a question for you. How you compare cleaning versus the HEPA filters? I have seen sometimes people saying, I clean my lab, I don't use the filters. I just take the cloth and I clean it twice a day. That's enough for me.
No. HEPA filter has its own role and it's very important. Our basic instrument in laminar flow, we have the HEPA filter inside. So you cannot do without HEPA filter. HEPA filter is there. See, for me, what I feel is that other than this cleaning is in regular process. We have stopped using alcohol and all, as Dr. Sharma said, the material and the lab area and atmosphere and all this thing. But what I feel is more important is how many people are entering in the lab, how many times they are entering, what stuff you are having inside the lab, and this all matters for maintenance. This everything has to be considered. Like if in a small lab, if 4 people are standing inside, then definitely it is going to create a problem. If we restrict the number, I think that is the best way. That having less number inside, so less chances of getting problems out of our control. We can very well control it.
Right.
About the
please
molecular sieve, air scrubbing, and activated carbon filters, how necessary they are, because we want it for the benefit of our audience, and how much they improve, because we have had lovely talks on that. So we wanted your opinion, panel's opinion regarding the molecular sieves and activated carbon, which is basically what the coda has.
Yeah.
Plus the HEPA.
Yeah. We also use microbial settle plates. So we will expose settle plates around the laboratory every few weeks and incubate those to see if we grow any bacteria or molds or anything like that, because we shouldn't. But that's just to see what the background contamination is.
So blood agar plates on different locations is the lab and the percentage to find out versus swabbing.
I would like to make a comment before because I have to leave. Is that okay?
Yes.
Yeah, please go ahead.
Oh, okay. So first of all, about cleaning, I couldn't see who was talking, but I totally agree that it's very like a lab individual. I can tell you from my experience, because we had not a very big lab with a lot of cases, like 3,000 per year. We had the rule that after each case, we are cleaning the bench with sterile water, and we are changing all gloves and head covers and everything that we could make easier. And we were cleaning the lab only by the end of the day. We kept the lab closed with we had the coda filter, 2 coda filters in the air, and all the inline and the incubators, etc. But once, and this I wish to share with you, I saw that fertilization rate is low for 2 days, and since we had a lot of cases, we had a very quick a very quick conclusion about it. So what, like I said before, I term it as a clean table. We don't ask what's happening. We just stop everything. We are changing everything, all the filters, all the disposables, everything is going to the garbage, and we start from new. So like a clean table, we don't know what's happening and we don't care. And another thing is that you have to trust your intuitions, embryological intuition. If you feel that something is wrong, do a clean table. It's not so costly, and you just make sure that you will start from a higher degree of safety. And I'm sorry I can't go on because it's a very interesting discussion for me. So I just thank you so much. And
We miss you, Yana.
Thank you.
Thank you. Thank you so much, Dr. Yana. Thank you so much for coming and joining.
Bye-bye.
Yeah, you want to ask something?
I wanted to, but she's leaving.
With the permission of moderators, can I ask a question to the panelists?
Pleasure, sir. Please go ahead.
We have seen many labs, they keep some sort of activated charcoal in the tray or some vessel or some utensil in the corner of the laboratory and believe that this will take care of the VOCs. How true is that?
I want this to be answered by Dr. Kalsi. I have heard him saying what is the correct answer. Dr. Kalsi is here.
Yeah.
Dr. Kalsi.
I think he had some problems. He said he may be available, may not be available. But
Please
we could take the entire panel's opinion absolutely on this matter. Open activated charcoal granules. Aye or nay? Yes or no?
Dr. Yana, no?
No, I think either you do it properly or you don't do it, because I don't know, like Dr. Sanjay has a lot of experience, and he is doubting if this is okay. So if you have a doubt, there is no doubt. Okay, so don't do it. You have to do it properly. There are a variety kinds of filters with the active charcoal, with but everything is there, and it's you have the the factory, what's it called, all the documentation that everything is okay and it doesn't make any harm to the atmosphere and to the ambient air and whatever. But if you take a dark activating charcoal, you don't know what it's doing. Maybe you don't know the source of the charcoal. I would not do it.
The answer is actually that. The answer is actually that the charcoal is not the black hole which is going to absorb everything out there.
Right.
It needs certain pressure, right? It needs certain pressure to absorb things. We have to consider. I have seen people putting charcoal in the water of the incubator, and I do like this. So please stop doing all these things now.
Oh, so we basically one more question for the panelists. So this comment was it in the Cairo consensus, was putting vessels of oil inside the incubator as a VOC sink. And has this been practiced? Does it work? Because we would really like to use it. And we have done it for a few years, but we'd like the panel's opinion on how it works and does it help?
It's not something we've ever done.
Sorry. Dr. Lynn?
No, we haven't ever done that.
You know what I'm sorry. Have you seen it? I'm sorry.
Okay, Yona, please go ahead.
I always say when I'm going to troubleshooting, I'm learning other things. When I will stop learning, I have to stop my work as embryology. So this is a real new thing for me. I never heard about it before. You know, I think that you should change the water in the incubator. If you see that it's a little bit contaminating after 5 days, you change the water after 3 days. Or you know, the only thing that I would trust is to put a copper tray inside, and the copper is a kind of absorbing bacteria, and it has something, but that's the only thing I was putting inside sometimes. But no, you have the incubator with the original tray. You change it in a time which is you are sure it's not going to be contaminated. You change the water. I didn't hear about putting oil in the incubator. I have no experience, but I think you know, intuitively I won't do it.
But don't we do it every day, Sally? Don't we do it every day? We make the dishes, we put the media, we put the oil. We do it every day.
I think I was very intrigued. It was part of the Cairo consensus, and they actually had a comment on it. And I started wondering, because he said you could put like jars of oil. And I'm like, all right, okay, that seems nice. But I like you said, it very few people have actually practically used it. It just popped in my head. So so Gaurav, can we take pH, because until we have Dr. Yona and the whole panel, we really like that topic, because that's gonna
pH.
be like, yeah, pH. So pHI versus pHE, and how do we maintain, and the temperature pH conundrum. So if we could take it. Hello.
Yes. I will tell you. When I was a student in the university, in my department, there was a very great biochemist, and he was teaching me that when you take out the medium and you take out and you take the cover, so pH changes immediately. Okay, so until the time that you put the probe inside, it takes time, and then it changes. The only control that I had inside the incubator, inside for the nuded oocyte, is actually the color of the medium. Okay, because I didn't want to expose it. When you try and you take the probe and you start, no, I don't think I would do it. That's what I don't think that. I'm looking at the color. If it seems fine, because we have, you know, the pH. We have done our own probes of colors. If the color is fine, we don't touch it.
Okay, all right.
Yes, I want to comment something.
Okay, yes, please.
Vijay sir, please. Dr. Vijay. I think he's not listening. Silently.
Sure. So another follow-up question on Dr. Yona comment, ma'am's comments, basically that phenol red indication and the color that we have of the media would be sufficient, because if we take it out, we are changing the pH regardless. So, but then the color doesn't really change between 7.2 to 7.4, and as we know. Most of the media have different ranges of pH to work at. So what would be your comments on that? Is 7.2 better versus 7.4? Does it change according to the cell stage? And how should we tackle it? How should we maintain the pH if we know the color looks fine, but we are still worried because that we are not getting enough blastocyst or we are not getting enough fertilization? What should we do at that?
If you're not getting fertilization, something is wrong. I'm not sure about if it's the pH. I told you what is my point of view. You know, you remember a clean table. I will tell you something. I still remember it. Many years ago, we had a very close contact between the what we say the first and second generation of the IVF embryologists. And once Dr. Ana Vega stopped getting fertilization in the ICSI. And what happened was that she made very, very tiny droplets for the ICSI she prepared, and then she put the oil, and the very short time caused a change in the concentration of the medium, and this also led for a change in the pH, and she found how to do it. She made a little bit bigger droplets and not on a warm plate, but these changes in these tiny, it depends very much which droplets you are using. If you are using and you don't get fertilization, tiny droplets, it might be the same reason, because these tiny droplets are evaporating and the concentration between the ingredients it changes, okay? And it changes all quality of the medium. I would say if you don't get fertilization, again, a clean table, because you don't really know why is it. It's because I don't believe that from 7.2 to 7.4, you stop getting fertilization. Maybe fertilization rate is a little bit lower, which I don't believe also, but it's not the reason. Start again.
So follow-up questions, Dr. Gaurav, do you want to?
Okay, we are done with the second case. Now we are going for the third case. Okay. Now this time the clinician is very happy. She gave the 5 oocyte and the embryologist was able to fertilize all of them and created the best day 3 embryos and the blastocyst. So they both are very happy. So in happiness, suddenly the clinician decides, I'm too happy and I have planned a trip to US and I want to align all cases together and I want to do 10 pickups in one day. So I want to ask my dear panelists that how you do it. When you have 10 pickups in a day, we talked about lots of things, right? This exposure to media incubation, to VOC, to people, this, that. But how we manage 10 pickups, how we start with the dish preparation. Charu sir, you have lots of experience in it. You are the man who does lots of batches from Kashmir to Kanyakumari. You tell me how you make the dishes.
No, yeah. Now this COVID era is reduced from. It's not from Kashmir to Kanyakumari. It is only from Indore to Indore. Anyway, this is very good thing and very good question, and we should understand basically the efficiency also affects the outcome of your procedure. And as you rightly said, if 10 cases are planned, then it has to be planned in a well planning matter. Like what I do in my places, if I have to perform 10 cases, I ask them to keep it in batches, like 3 or 4 cases in morning hours. Then there is a gap of 3-4 hours, 6 hours in between. Then after 6 hours, another batch of another 4-5 patients in the evening. So that also gets us more relaxed, and everyone in the lab and everyone working in that unit also get some time for relaxation. Second important thing is, if they are planning to have 10 cases in a day, then the basic infrastructure we need to see. They should have at least 2 or 3 incubators so that it can be done. And nowadays 2 incubators are very common now. People have understand it, the importance of incubator, and most of them. But still, again, the question comes, like if they have 1 benchtop and 1 box type incubator, then again it creates problem, because again you are going opening and closing incubator many times. So as far as my experience is concerned, I always manage it in the way that there should be sufficient person working with me, at least 1 person. And this is what mostly happens in our case. Like we go to some place and we do just after pickup, everything gets off from the picture. No one is there around you and you are sitting alone and doing everything. So in particular such cases, it's always better don't keep more than 5 cases or 6 cases, so that you can easily manage. We are more concerned about the gametes. Like the first pickup is done at 8 o'clock, and by the time you finish the 10th pickup, it is already 2 o'clock, and then the first pickup is unnecessarily compromised. So that is how we can manage. Dish preparation, definitely it has to be taken care, and a day before Means in my case, I can tell you that I reach a day before and I prepare it myself. So I take all the precautions. No compromise.
No problem. I know you said you are very meticulous at your work. So I asked you because I see lots of corporate people coming to me and said, we did 25 pickups yesterday, we did 30 pickups yesterday, we are doing this much of pickups every day. So Line, how you see this? How many cases you say this is maximum case we should do?
No, I have seen this in Belgium. See, in their lab, they used to do daily some 10 cases or 15 cases, sometimes maybe 20 cases also, as at VAB lab. But they have 16 incubators. You know, the 16 incubators and the team of some 20 people, junior, senior embryologists working in batches. Like the first 4-5 pickups is done by some other team, then another 4 pickups done by some other team. So it is possible, provided you have that kind of basic infrastructure. Like I don't think in India we can expect a doctor doing 20 pickups in a day continuously after one after another. I have not seen it. Maximum 5-7 pickups at one go you can manage, but not more than that.
Dr. Lion, nice. Any comment from your side that how many pickups they should do and what is your idea about it? Because you're a director, you have the team of 10 embryologists, right? How you manage them? How you manage the case?
Well, we have, if we were doing a large number like that, we would equilibrate all of the dishes overnight. So we'd prepare them the day before, so they were already made. And then the way that we work is we would have different people on different tasks, and we would have like a production line. So someone was collecting, then those oocytes were being processed, going through ICSI if they needed ICSI, being inseminated, so that we kept the timescales where we needed them to be.
Right.
But we would just make it a longer day, but keep the process rolling. So I would look at having some people come in later so that they could work a little bit longer. But even then, we'd always aim to be finished by about 5 or 6 in the evening, having started theatre about 8:30 in the morning.
That's right. Dr.
We just have it like a conveyor belt.
Dr. Yona, you want to comment something?
Yes, as I told you, I was the director of a big unit, okay? And Dr. Lim said it's not, in many cases, it's a very, you have to know how to handle it. First, as you mentioned before, you have to have everything at least double or even more. You can't work with one incubator and do 10 cases. That's impossible, okay? So you have to leave, if you don't have the personal incubators, you have to have at least for 10 cases, I would say 3 to 4 incubators, okay? Now, if it happens once in a while, okay, but if it on a daily basis, you have to have 4 incubators. I would suggest to prepare everything a day before. If we what we are doing is to prepare the dishes with the name and with the labels of the name, everything. Everybody knows where is it located in the incubator and everything, okay? Now, to work in 2 shifts. Okay. For instance, we start at 6:30 or 7 o'clock, then the other shift come on 2:30, and on 3 o'clock they start working. When there is a coordinator to explain them, they are just continuing the work exactly from the point of the first shift of embryologists. So you have to have at least 7 embryologists in the work, because less than 3 embryologists cannot do the work in one shift.
Right, I agree. That's the problem with the clinician here. She is planning 10 pickups with one chintu only, right? So one man cannot handle 10 cases in a day.
This is a team effort. It's not one person, it's a team.
I got your point. So we are going for the next question regarding this culture preparation. So whenever people go to the conferences, they always see somebody saying single drop culture, somebody saying group culture. what is this all about? What you do in your labs? Sharma sir, if you are there, please put a light on it. What you do in your lab and how significant is single culture versus group culture? What do you see now?
Yeah.
Chello sir is also here.
Can you hear me?
Really
Sure,
sorry. I'm going to have to leave. Somebody needs me to go and do something. So I'm very sorry. I'm going to have to drop out.
Nice. It's
Thank
very
you.
pleasure to have you here. Thank you so much.
Thank you,
for giving your
Dr.
time.
Lin. Thank you so much for coming
Thank
and joining
you.
us.
Thank
Thank
you.
you. Thank you. Thank you.
Sharma sir, please.
Yeah. See, there is a different philosophy for both the ways. They say that if you do the single drop, if one embryo is bad, it will produce some toxins and it may affect the other. So it's better to, do the single culture. While the other philosophy is that, there are some, local, paracrine type of, products which are being produced by healthy embryos, and they can, salvage the poor quality embryos as well. So what I feel is that if you have a network of oocytes, okay, then it is better to do the group culture in those cases, especially, so you select the patient, a patient who is elderly, who is having a poor ovarian reserve. So there, you may have to do a group culture, but group does not mean that you put 10 embryos or 10 oocytes together. So you put, say, 3 to 4 maximum in one drop. And if you have, say, many oocytes, and then also, I would not like to put all the eggs in one basket. In some, I'll have a single embryos, and in some drops, I'll have more embryos, so that you get best of both the worlds.
Right. I got it. Chello sir, you wanted to comment something?
Yeah. In my life, I have never done group culture.
Why so, sir? Put a light.
That's been my, you can say that it's been my principle from the day one. I always keep single in one, single per droplet, one oocyte per droplet from the time of collection.
Nice.
And it has never disturbed my outcome by any chance. Has there been any paracrine or an endocrine or a cytocrine factor in this process? I think in the 40 years, people would have isolated those factors and would have commercially exploited it by this time. So that very well says that in the era of time-lapse monitoring, what we are seeing, it is all individual culture.
I know, it's a bit like that.
So it is the culture condition rather than the way you culture. That's more important here.
So it's shut down.
Dr. Yona, you want to comment something what Dr. Chello is saying?
Well, I think it's very individual. If he feels like that and he has a successful system, so he should continue. Me personally, I personally like a larger droplet and to put 2 or 3 embryos. But other embryologists in the lab, they like the single droplet and the results are the same.
Same,
So
I agree.
I think that's what we should do, because if it's the same and if he feels safe, so I think he's right.
My issue with the group culture is how you see the traceability of the embryo. How you know what was the previous grade of the embryo, whether that was a A grade embryo earlier, that was a B grade embryo earlier. So it happens when you have a drop culture, you can at least trace the embryo and see the proper growth throughout from the P until the blastocyst.
Exactly.
But be the A grade or it has changed to different grades in between.
Exactly. In the group grow, there is a very big disadvantage because you can't detect individually each embryo. So
yeah, exactly.
Any other comment from the panelists?
So we had, so I just remember, I think we have Dr. Jafar Ali here, and I have had a discussion with him a few years back regarding autocrine and paracrine. He has done a lot of work on group culturing embryos in very small droplets to improve blastulation rates. So if he's there, maybe we could get some input, because that's a completely different view from what we have heard.
Dr. Jaffer,
Is he there?
he was there.
Yeah, Dr. Jaffer is here. Dr. Jaffer, sir, please.
I think he's not.
He's in.
So do we have any differing viewpoints on this?
Dr. Chandor want to say something?
See, I would like to bring up this topic of oviductal fluid and the uterine fluid concentration differences in the constituent qualities of the media, based on which the sequential and other things we talked about for almost around about a decade's time. So if we can measure these fine differences between 2 millimeters of the distance in a physiological system, can't we think that in the culture medium of around about 30 microliters droplets, we could have identified the cytokine and the autocrine or a paracrine factor by this time? It has never been shown to be this one. It is only perceived. It's only perceived.
Yeah, but Dr. Vijay, even the oviductal versus uterine fluid is not something that is universally accepted.
Absolutely, absolutely. That's why I say that in the era of time-lapse imaging, when we are culturing individually and we are monitoring it individually from PN till the blastocyst stage, this whole topic of having a group culture itself doesn't even fit into that matrix.
Doesn't fit into AI, doesn't fit into the future.
It doesn't fit into that matrix.
Sir, in time-lapse, we use well culture where we have both things.
That's also there, and there is individual. This one is also there are two kinds of this one. In well, we use only 50 microliters droplets.
Right.
We don't use individually 25 microliter droplets.
So, Dr. Vijay, you use 50 microliter droplet for one.
I use a 30 microliter droplet from the beginning for one oocyte, 30 microliter droplet, and I change the medium on day 3.
Well, the only advantage that I see for myself, for instance, I used to put a 0.2, so 200 microliter for 3 to 4 embryos, covered with oil. It's faster because you are checking 3 to 4 embryos in a faster time than you are, moving the individual. But I don't find I don't find any kind of advantage in the book
doing it together.
Yes.
Yeah.
Siley, there is another point.
Yes.
Because it all depends on the efficiency of the person who is doing all those things. So we have seen many labs who are doing droplet cultures, and their embryo quality and the subsequent pregnancy rates have gone down.
Oh.
Yes, because the embryologist or the person who was preparing the dishes wasn't that efficient, and they were not taking care of the osmolality point, right? So if you are doing those things and you are not very particular about your dishes and all those things, you are in fact doing harm to your culture system. Another thing which even Dr. Alex always emphasizes, the effect of VOCs would be even more profound if you are doing droplet cultures and if your mineral oil is all intoxicated with the VOCs. So if you have those things in your laboratories, if you are doing larger volume culture in maybe 4-well or single-well dish, it's better than doing droplet cultures. So it all depends on how your team is working and how your environment is. It's not just one factor, that the group culture or single culture or droplet culture or larger volume.
I agree.
This is the beauty of embryology,
Required.
Black and white.
Yes.
I agree with you, Dr. Sanjay. I think I agree with every word now. Really, you just said every word. You know, thank you.
Perfect.
Well, thank you. Thank you.
So the answer is it depends. It's always the answer. And for osmolality, we had one slide. We just wanted to make comments, Dr. Gaurav, regarding the Jason Swen paper on how to make the dishes. And like Dr. Shukla said, it all depends. But if the audience could go through the paper, it really talks about how the drop size, the oil overlay volume, the blower on or off really make a difference in terms of osmolality pH maintained. That was the point we wanted to make.
Okay.
And should we go on, Gaurav?
Yeah, you want to take this?
Yeah, I don't have the slide running on mine, so you will have to change the slide.
Okay.
Yeah. So are we done with the so incubator? Gamete
Yeah.
handling. Pick one.
I want gamete handling.
Yes. So
Yeah.
gamete handling. So we have talked so much about the culture system and what drop sizes, whether to do open versus closed systems, and now we want to really get the panelist opinion as to how do you handle the gametes outside. What good buffers do you use? Do you use it with bicarb? Do you equilibrate, not equilibrate, combine versus single? How do you do it? How do you do it? How do you make sure that the peri-implantation of gamete is taken care of? It's open to the panel. If we could have Dr. Charu Joshi starting. Sir.
Yeah. See, gamete handling means we all know this HIPPIS is the best choice right now available for us. And I prefer to use HIPPIS buffered media for all procedures doing outside the incubator. And particularly for micro manipulation also, as here it is written, I prefer to have HIPPIS buffer drop rather than culture media drop. Of course, it depends on the time taken for the procedure, but then usually you don't know when you start doing the procedure and you come across some slight situation, some difference, and then you may need some 30, 20, 40 seconds more or a minute more. Then probably HIPPIS buffered media is a choice, is a better choice for me. And as far as handling is concerned, yes, not many gametes at a time. Like for example, if oocytes denuding has to be done, you can take maximum 5, 6 oocytes at a time, and then as fast as possible you can do it, maintaining the time duration, because that is also very important. And I think along with time over the years of experience, one understand about this particular thing, that the exposure time and handling and using a proper size pipette and so many things we need to consider for handling the gamete, because I have seen many times it has seen that the oocyte is slightly bigger in diameter, and as a set protocol, if someone has told me that okay, you have to use 140 micron denuding pipette for handling oocyte, and if it is slightly bigger in size, then I know that it is not going to work, but still people perform, and then there is squeezing, and then there is outcome is compromised and all. I have seen these people doing. So my take on this is that you have to really see, and for me it is along with experience, one can understand that there is nothing fixed, like you have to use this only and you cannot do this. There are many ways of doing any procedure in different ways, and every person is doing it differently. But then you have to give importance to all these things while handling the gametes.
So science and art. So we are a combination of science and art.
Yes.
Yeah. Yes, Dr. Raj.
You're asking me?
Yes.
Okay. I want to ask you, you are preparing your own medium or you are buying commercial?
Buying commercial.
So why look, there are most of the companies, they present medium for handling oocytes, for micromanipulation. I would choose one line or two lines parallelly and stick to it, because it doesn't matter if you are using HEPAX is good when you're doing it outside, but anyways, you have to have fresh droplets. So it doesn't, to my opinion, it doesn't really matter. It depends very much individual what is good in your hands, okay, and what is good in your hands and what do you believe. I use for micromanipulation, I'm using the based on HEPAX, but with the bicarbonate. But again, I'm doing very few oocytes, 2 to 3 together, and I change all the droplets. So I think again, it's what is good in your hands. If you feel better and you have good results with the HEPAX, so you do it, a part of it you are doing with HEPAX, but you have to choose a line and you have to stick to it. Generally, I believe in 2 parallel lines, because if one is not, if something happens to the medium, you immediately see it because you have another line of medium. But that is my opinion. What is good in your hands?
So I think in gamete handling, we just wanted an opinion, because some people still do it under only bicarbonate buffer mediums, micromanipulation.
Sorry,
I said some people still do ICSIs under culture media. So we wanted to make that point that, gamete handling buffers would probably be a better option to do micromanipulation steps. And the second question was, we have the EPs versus MOP as good buffers, and I think most in the panel use EPs. Am I audible?
Yes, but I have some problem with my own. Okay, so this is what. Okay, again.
And there are some companies in the market who have this bicarb EPs combination, which you have to equilibrate to use, and then you can utilize it in and outside the incubator alternately. So I just wanted the panel's opinion whether they have any practical experience with it, and because it was in the market, so I thought whatever commercial gamete handling buffers are available, what is the preference of the panel? And the panel, I think, has said EP mostly unanimously. So, Dr. R.K. Sharma, sir?
Yeah. See, outside the incubator, I prefer only HEPAs only. I do not use any bicarbonate or a mixed buffer with that. And at the same time, even with the HEPAs, we have to be fast in doing the things. Don't, as Charu said, don't put too many eggs together for ICSI. And depending upon what stage of your, learning curve you are, you may start with one oocyte per dish, and over a period of time, you keep on increasing 4 to 5 oocytes at a time, not more than that. And then quickly you wash it with a bicarbonate buffer and put it, in the bicarbonate buffer after that.
That's a great tip, sir, because anybody who's starting to learn ICSI, they need to do it slowly and steadily and take all the precautions. Okay, Gaurav, I think we're running out of time.
I just want to make a last comment on this timing and all. So whenever I have my juniors and those who have to train, I always give a stopwatch to them. I want them to write how much time they take to denude 5 oocytes, and keep a track of it, whether they're reducing it or not. So over a time of 1 to 2 months, they're gonna reduce it to an optimal one where I want. But tracking is also very important thing. Okay.
Yeah, that's that.
Okay. So
yes, sorry.
The clinician is quite happy. We are doing 10 cases a day. They're quite happy. They're making good blastocysts. The Chint is also very happy. Now clinician says, I want to spend some money. Why not to buy some new incubators, because we are increasing the number of cases. So my
Where is the clinician that says they want to spend money? But okay.
I have that one.
It is the embryologist who will ask. Clinician will never ask.
So this
Yes,
is a kind-hearted clinician who want to spend money rather than jewelries on the incubators.
Very rare.
And the Chintu is quite happy and asks, Chatur, bhai, please help me. I want your help. Which kind of incubator I should buy? I have no idea about the incubators. The Chatur says depends. So what is the answer of Chatur? Can you please decipher that? What is the meaning of depends? The comment from the panelists.
How do you decide on a new incubator for your board?
Which incubator we should buy in the lab?
We want to expand our embryo culture possibilities. We want to do more.
Like I have a box incubator in the lab. So what should be my second incubator? Whether I should buy the TriGuest benchtop incubator, or I should buy again a box incubator, or I should go to the time lapse straight away.
It depends how much money she wants to spend, because I would go on the individuals, like you show in the here in the picture, down in the picture, because these incubators, first of all, the risk for mistakes is much lower. You just reduce the risk of being mistaken with the dishes. So secondly, when you open it, it comes very quickly to the temperature, and I will go on these ones today. I think.
Sharma sir, if one has a box incubator, what is your suggestion? What should be the second incubator?
See, it depends where you are practicing. Like if you are planning to buy TriGas and the TriGas is not available in your city, then what is the point?
Right.
So better buy a box, another box incubator only.
Can I make a comment here?
Yeah, sure.
Hello.
Yeah, please. Charu sir, please go ahead.
My opinion about this thing is, if my clinician asks me that I have money and I want to spend, I would rather than first assess the situation, how many incubators are required. We already have 1+1, and still if the number of cases are more, then definitely we should plan for an additional incubator. But the main advice to the doctor will be in this particular case is that better, instead of spending on the new gadgets, you spend on a gadget like thermometer or an CO2 analyzer, or some kind of quality control instrument, or some improvement instrument which can be help you in improving the culture conditions of the lab. Second thing is,
happy to do that.
Yeah, and the second thing I would like to mention here is that if given a choice of box type or a benchtop incubator, I would always say that first you have to see the availability of the gases. I am telling you, I am facing this problem at least at 4-5 places, that the certified cylinder liquid, this nitrogen gas cylinder saying 99.5% pure nitrogen, and when it is attached to the TriGas incubator, it was showing high concentration of oxygen, and the company people says this is not a medical grade nitrogen, and that is what the problem is. So before going for a benchtop incubator, you need to understand the requirement of that, and you should make it sure that you should have an premixed gas cylinder always available, or the gas supplier should give you the best possible gas. And another important thing is that nowadays we have very good incubators in box type only, TriGas incubator only. So rather than going for a benchtop incubator, if I have to go for a second incubator, I would like to go for a TriGas box type incubator, because suppose your culture incubator, working incubator is sometimes something mishappening is there and something goes wrong, at least you can use that another box type incubator for your practical purpose. Benchtop incubator has its own limitations. You cannot perform your all routine procedures in that benchtop incubator. So that's just the advice, that if you have to go for a second incubator, go for a box type.
One has to think wisely, because this TriGas gases are quite costly as well. If
Can I
our
come in?
one cylinder costs 8,000 rupees.
No,
Can
that
I
is
come in?
costly.
Please,
Costly.
Vijay sir,
That is,
please.
sir, 1 minute.
Okay,
That
I
is
would like
costly.
to invest. I would like to invest my money onto an incubator which has its own sensors for the gases as well as the temperature and allows me a calibration port.
And the gadgets
I can cross test it with my external
Sir,
gadgets.
sir,
which is
Vijay sir,
Yes,
with
sir.
all due respect, the problem here is not the calibration port. The problem here is the gas supply.
I do understand.
If you are not getting 100% nitrogen, then what calibration is going to do? That is
Absolutely. In that condition, having a tri-gas incubator itself will be waste.
Yeah.
Correct.
That's why I would like to have an incubator which has its own sensors for the gas concentration display, plus it gives me a calibration port wherein which I can test it externally using my calibrated instruments that whatever display it is showing is right.
Dr. Vijay is absolutely correct, because we have faced this problem. The percentages written on the tri-gas mixed gas incubator is not correct. Imagine what happens when you don't know what is inside. And so we just checked the pH, and we found out, because we checked the pH with a handheld meter, that something's really off. But then if you found out with a calibrated port, that would be so much.
No, and if you still keep on insisting this tri-gas incubator supplier, that there is some problem. There is some problem.
I don't insist on tri-gas incubators at all. I don't insist on tri-gas incubators at all. I straightforward say that a well-working simple carbon dioxide incubator is much better to a tri-gas incubator with a poor gas supply.
Correct.
Study suggests something else. What to do? A paper saying live birth rate is high, live birth rate is high, live birth rate is high. What to do then?
Say, if you list out last 30 years of all publications mentioning 10%, 5% advantage over this, if you total it out, it comes to 210%. And nobody is getting that much percentage of pregnancy by any chance.
Sir, there is a recent paper of Nature. There is a recent paper by Nature which says about the biphasic oxygen from 5% to 2%. How you maintain it?
Not 2%, not 2%. Some people are even trying with 0.5%.
How you maintain it? I just want to know.
See, that's what I'm saying. If you say that by doing X method, you will get 10% increase in pregnancy. By doing Y method, you will get 5% increase in pregnancy. By doing Z method, you will get 10% increase in pregnancy. You list out all these things on the left-hand side and you add the percentages, it will come out to 220%. By that means, if I add these things, if I transfer one embryo, I'll get 2 babies then. Which is not true.
Okay.
Gaurav,
Statistics can be a two-way sword. Statistics can be two-way sword.
We tend to forget that these reports are coming from very well maintained and very good laboratories. Okay, the moment we read a paper, we believe that our laboratory is as good as theirs. And if we follow their protocol or we follow their way of doing anything, we would replicate the same result. This is one of the things that we tend to forget.
I agree with Dr. Vijay Kumar Chellu that we get the same results with the box incubator.
Absolutely.
We're not that bad. Believe me, we're not that bad. Sometimes I just shut down my Mink incubator, benchtop incubators in the winters. I know it is going to behave poor right now. In the extremes, in the May and June, I just shut it off. I know it is going to behave weird. I know this tri-gas is going to condense later in the winters. It has a different density. It is not going to give me the same what has been fixed earlier. So generally in the normal days, I use Mink incubator, benchtop incubators. But when I have extreme heat or extreme cold, I avoid using tri-gas incubators. Pre-mixed especially.
Very nice tip, Gaurav.
Thank you. I have to leave. Thank you so much. And
have a nice day, Yona.
Yona, madam, we are just asking about those. We just want you for the last comment. We are just done, I think. So we are quite happy that we have done all the process. Now the clinician Alma is happy. Now Chatur is happy that, and finally our Chintu is also very happy that he knows what is the embryo culture system. He knows what is the VOC. He knows what is the temperature, pH, and what type of incubator one should buy, and what all factors are going to impact the culture system. So to all the Chaturs out here, Dr. Sharma, Dr. Yona, Dr. Charudat.
Gaurav, I just want to make a one last comment. During the COVID time, most of us are putting on the mask the whole day. The whole bacteriology of the mouth is different, and the embryologists who are using the mouth aspiration sets, they would be giving more VOCs to the culture media. So they should be careful, and they should use the hand pipetta rather than the mouth aspiration.
I agree with you. I agree with you.
And preferably in the lab also, they should keep on putting on the mask. Otherwise, they would be producing more VOCs from their own mouth only.
Thank you so much, sir. This is the advice Chintu always
You
wanted.
have to supply oxygen for them, I think, all day with the mask. Okay.
Sally, you want to say something?
Yes, we absolutely loved having you in this panel, and extremely invaluable experiences. I think we have around 200 to 250 years of experience in the Zoom call right now, and it's just I really want to. We really want to. Me and Gaurav really want to pick your brains all night, but we know you have homes to go back to, and this was a lovely opportunity. Thank you so much for giving us the time to discuss quality in the IVF laboratory. And
thank you so much.
Thank you. Thank you. I enjoyed it more than you enjoyed. Thank you so much.
Thank you.
Saili and Gaurav, I would like to ask you a favor to send Alma, Chintu, and Chatur to IHERA. We would like to confer some awards to them, because I would like to confer gallantry award to Alma, who believed his Chintu, her Chintu, at the third attempt itself. to brave the batch. And yes, and Chintu, who performed so well and learned so quickly. So I would request Dr. Ved Prakash to organize an award ceremony for them.
That goes to Gaurav. You're one.
Thank you so
So
much.
I think thank you so much everyone for joining us, and thanks to Dr. Yona, Dr. Alex, and Gaurav, Shyali, Dr. Vijay Chalur, Dr. Charda Joshi, Dr. Shuklaji, and all other panelists, Dr. Lane Nice, and our coordinator, everyone, and MCure for sponsoring this event. And thanks to Dr. Jafarji, who is sitting here also. Sir, do you want to say something here at the end? Yeah, he's here. Still
Hello,
60
Dr.
people
Ali.
are attending this program.
Hello, Dr. Chapa. Thank you. Thank you so much. It was a lovely day, although it's it's the weekend. I asked it's Shabbat, but I enjoyed it, believe me.
Yeah.
Thank you. I just have to go to family obligations. Thank you.
Thank you. Thank you.
Okay. Bye-bye.
Sanjay sir, do you want to say something? आपका काम आ गया आपके लिए.
Dr. Jafar Ali is speaking, but we are not able to hear.
We are not able to hear.
So
we are not able to hear your voice. Sir.
Yeah, just a formal vote of thanks to each and everyone, like our attendees, who are most important to us, who were very patient to hear, and who were with us for almost 3 hours, and all our speakers and panelists and coordinators, of course, moderators of the panel, who have done a splendid job in in digging out all the information and the expertise from all our esteemed panelists. So thank you very much from the core of heart. Thank you.
So at the end, I think I want to show some slides for Fertivision. That wonderful meeting is going on. It will be on 10th and 11th, and there are so many workshops. If you want to attend, please attend and join for Fertivision 2021. There are so many workshops. You may be interested interesting in this workshop. Please attend this. These are the workshops: andrology, histoscopy, and challenges in OPUET, regenerative medicine in ART, so research methodology, setting up and maintaining ART lab. So these are the workshops if you want to attend, where very good workshops are going on Fertivision 2020. Thank you. Thank you, everyone. Thank you. Thank you. Thank you.
Tomorrow, if anybody is in Kolkata, please catch up with me.
तो बहुत अच्छा हो गया, you know, अभी भी मतलब 50 people are sitting here over here.
Yeah.
When we finished here, at that time it was 70.
Yeah.
Good.
I think the highest was there were around 150 people.
Yeah. But you know that today so many workshops are going on.
Yeah.
Even that Kolkata program is going on there. But still we have so many people. I think it is good number.
Yeah, it is.
Yeah.
Look at the chat box.